The highly engineered construction of the intermediate level vault provides the greatest isolation quotient, or IQ, of all radioactive waste disposal units in the E area low-level waste facility. IQs can be determined for each of the 4 potential radionuclide pathways from a disposal unit: intruder, air, radon, and groundwater. Here, the IQ for the groundwater pathway is discussed. If the simpler disposal units, the slit trenches and their larger cousins, the engineered trenches, are assigned a relative IQ of 1, meaning they provide the comparatively lowest degree of waste isolation, then the intermediate level vault provides the highest relative IQ, an IQ of 233 trillion. That's 233 trillion with a T. Therefore, these vaults are reserved for wastes that require the greatest isolation. The intermediate level vault is highly engineered to completely encapsulate waste within a grout envelope constructed within a sealed underground concrete structure. The vault will only hold about 4% of the total disposal capacity in the E area low-level waste facilities subsurface disposal units, while containing about 76% of the subsurface disposal units' total radioactivity. Safety, risk reduction, and regulatory health and environmental compliance are verified through a system of groundwater monitoring wells near the intermediate level vault. These wells will be used during both the E area facility's operational lifetime until approximately the year 2020 and through the following 100-year institutional control period. After the institutional control period, a final closure cap system will be installed and groundwater regulatory compliance will be verified through a monitoring well system located within 100 meters of the E area facility. The following animation depicts the construction characteristics, filling method, and final closure of the intermediate level vault, and illustrates why these highly engineered units provide such a high IQ. Intermediate level vault construction begins with an approximately 30-foot deep excavation. The excavation bottom is a minimum of 40 feet above the water table. The vault is constructed from the bottom upward with a 1-foot thick gravel drainage layer, a minimum 1-foot thick crushed stone construction base, a 30-inch thick reinforced concrete base slab that extends 2 feet beyond the exterior walls, 30-inch thick waterproofed reinforced concrete exterior walls, 18-inch thick reinforced concrete interior walls that create the individual cells, an interior leachate collection system, exterior permeable soil backfill. One intermediate level vault is currently in operation. It is approximately 279 feet long and 48 feet wide, and divided into 9 nominally 29 feet deep cells by the interior walls. An additional vault may be constructed in the future if needed. During the 25-year operational period, waste, such as equipment and containerized waste, predominantly in drums, metal boxes, and concrete containers, are placed in a given cell in layers. Each layer of waste is encapsulated in grout, which forms the surface for the placement of the next layer of waste. As each cell is filled to capacity with waste, a final layer of grout is installed level with the tops of the vault walls. Once the cells are filled, the vault is operationally closed by installing a 2-foot 3-inch thick permanent reinforced concrete roof slab. The roof slab has an overlying waterproof roofing layer. At the end of a 100-year institutional control period, final closure will be achieved by constructing an integrated closure cover designed to minimize moisture contact with the waste and to provide an intruder deterrent. From the vault roof slab upward, the closure cover or cap will include a layer of structural soil fill at least 40 inches thick, a 2/10 inch thick geosynthetic clay liner that acts as a seal to prevent downward movement of most of the water infiltrating from the surface, a 12-inch thick coarse sand drainage layer above the geosynthetic clay liner that diverts and directs infiltrating water to a surface discharge at the cap's border. The coarse sand drainage layer is overlain by a 1/10 inch thick geotextile filter fabric that separates the underlying sand from an overlying 12-inch thick layer of structural soil fill. Another 1/10 inch thick geotextile filter fabric layer overlies the structural soil fill, separating the soil layer from a 12-inch thick erosion barrier made of 2-inch to 6-inch cobbles, with void spaces between the cobbles filled in with a sand and cement mixture. The erosion barrier layer is overlain by a 30-inch thick layer of structural soil fill. The surface layer is 6 inches of topsoil that will be planted with a grass that will encourage transpiration of rainfall. Lengthwise along the vault, the cap will slope to either side at a 3 to 5% slope to facilitate rainfall surface drainage away from the underlying vault. The intermediate level vault is highly engineered, providing the highest isolation quotient, or IQ, of all E-area low-level waste facility disposal units. The vault provides an IQ of 233 trillion. That's 233 trillion with a T. Therefore, the vault is reserved for wastes that require the greatest isolation. To illustrate the high degree of isolation of the waste from the surrounding environment, let's follow the path of natural water infiltration through the cap and around the vault. The intermediate level vault area experiences an average annual rainfall of 49 inches per year, of which just over 14 inches per year infiltrates through the closure cap's topsoil layer. As the 14 inches per year of water migrates downward through the cap's upper backfill soil and gravel erosion barrier layers, 97% collects above the geosynthetic clay liner within the coarse sand drainage layer and flows laterally off the cap, exiting to a perimeter ditch where it flows away from the disposal unit. This interior cap collection and drainage system allows only about 4/10 inches per year of water to move into the lower backfill soil layer that lies above the intermediate level vault's reinforced concrete slab roof. Of the 4/10 inches per year of water that contact the concrete vault roof, 99.8% flows laterally off the sloped concrete roof. Less than 1/1000th of an inch of water per year will infiltrate the vault roof. This high degree of engineering construction and the operational method of encapsulating all waste placed in the intermediate level vault provides a very high IQ for groundwater and long-term security and safety for us and the environment.